Phenylalanine is one of the 20 amino acids that are used to make proteins within the human body. So just like any other amino acid, there's a chiral carbon, which is like the central carbon to which everything else is attached. That chiral carbon, alpha carbon, is going to have a carboxylic acid group where it's 2 oxygens, a carbon, and a hydrogen. It's also going to have an amino group or an amine group where you have a nitrogen and 3 hydrogens. It's going to have some hydrogen directly attached, and then it's always going to have some R group. Now, in the name phenylalanine, it's literally alanine with a phenyl group added to it. So if you check out the alanine amino acid video linked in the description below, alanine looks like this, where you have this carboxylic acid group, the amine group, the hydrogen still pointing back, and then you've got a CH3 group added to it. Now to go from alanine to phenylalanine, you remove one of those hydrogens from that CH3 group, and that instead becomes a phenyl group, which is where you have an aromatic ring or something that has 3 double bonds and then 3 single bonds, and then each carbon is directly connected to 1 hydrogen. So phenylalanine is just a phenyl group on alanine. With any amino acid, the first hydrogen that's going to be lost is a hydrogen that's attached to this carboxylic acid group on the alpha carbon. And in this case, that hydrogen is going to be lost at a pH of about 2.2. So at 2.2, that hydrogen's gone. Now you've got this COO minus, which is going to carry a negative charge. This NH3, nitrogen should only have 3 attachments. It should have 2 hydrogens and then 1 black carbon when it's neutral charge. So the fact that there's 3 hydrogens and then another bond to this carbon means the nitrogen's carrying a +1 charge. So we've got a negative charge and a positive charge, which are going to together balance out to 0. So overall, this molecule carries a 0 charge, but it's considered a zwitterion because there's a negative part and a positive part on the same molecule that overall makes the molecule neutral. The molecule is not just nothing's carrying a charge. As you keep going up in pH, the next hydrogen that's going to be lost, none of the hydrogens that are on this carbon phenyl group or even on this carbon, none of those hydrogens are going to be lost at any pH because this is totally nonpolar. This is equally shared. So those hydrogens aren't going to be like, hey, I can access your electrons better somewhere else, so I'm about to leave this. They got pretty good access to these electrons. These ones are going to stay. So the final hydrogen that's going to be lost is coming from this amino group, and it's going to happen at a pH of about 9.3. So at 9.3, now we've got a 0, and then we've got a -1. So overall, this molecule is going to carry a -1. But the physiologic pH, or the body's pH, is around 7.4. So at 7.4, that hydrogen is still going to be attached. And so you're going to have this zwitterionic form is what it's going to look like in the human body, where you have COO minus and you've got this NH3 plus. Now let's talk about this R group alone. So this R group, you'll see it's literally strictly black and white. All you've got is carbon in black and hydrogen in white. And because all you've got is carbon and hydrogen, those are all nonpolar bonds, equal sharing of electrons. So there's going to be no polar regions in this R group. This is completely nonpolar. And because it's nonpolar, these hydrogens aren't going to look at any other molecule and be like, ooh, I like your oxygen more, and start hydrogen bonding. So because this does not do any hydrogen bonding with any other molecule, it's also going to be hydrophobic, or fears water, isn't going to bond with water molecules or anything else that is hydrophilic. The other really interesting thing about this amino acid, specifically this phenyl group, is that these aromatic bonds, these double bonds can flip and go to other places, and this entire phenyl ring would still look the exact same if you moved where these double bonds are. The The only thing that's going to change is the actual location of the double bonds, but the polarity is going to stay the same. The amount of hydrogens that are not going to be lost is going to stay the same. The hydrogens that are attached to this molecule are going to stay the same. And it's going to be a completely different situation if any of these double bonds get broken. So this is considered aromatic, which makes it even more stable, even more hydrophobic, way less likely to interact with water at all. Alanine was one of those molecules that could be made in the human body. And so because of that, it wasn't considered essential. But adding this phenyl group onto the alanine, this is a pretty bulky molecule. And so this is not something that your body is going to readily make. Like this aromatic ring doesn't come from any other places in the human body. So this phenylalanine is an essential amino acid. You have to eat it in order for it to show up in the human body. This ring can be used in a whole lot of other places. So you can break down phenylalanine and make other things. One of those molecules that's going to take advantage of this aromatic ring is tyrosine. Phenylalanine, not going to be made in the human body. This aromatic ring has to be ingested. But once you've got this aromatic ring ingested, this aromatic ring is going to go on to make a whole lot of other molecules. The enzyme used to make tyrosine is called phenylalanine hydroxylase, or PAH. And if that enzyme doesn't work, then you're not going to be able to make any tyrosine in the human body, and you're going to have an accumulation of phenylalanine. So if your body isn't able to make phenylalanine hydroxylase, it isn't able to convert phenylalanine to tyrosine and other molecules later on down the line, you're going to have an accumulation of these aromatic rings, and that's not something your body wants to happen. Doctors advise those people to just be on a low phenylalanine diet. So avoid phenylalanine. They figured out most of the foods that phenylalanine is high in, and as long as you're avoiding those foods at a high level, you're not about to have any issues. But if you don't have phenylalanine hydroxylase and you start eating a whole lot of phenylalanine, this is going to just start accumulating in your body, and it can't be broken down.